Lecture 14. A couple things you need to know in order to be able to finish the homework. Okay, so first of all, one of the most important things is to recognize that various curves and surfaces are frequently given as level sets. In particular, and as a sort of, simple trivial observation, if you take the function x squared plus y squared, okay, then setting that equal to a constant gives you, well, equal to a non-negative constant, gives you the circles that are centered at the origin. And if you take the constant to be r squared, you'll get the circle with radius r. Okay, so circles are frequently given in this way, where it's the level set of a function like this. If it's a circle centered at the origin, it's given as level set of this exact function. If you want to have a circle centered at hk, you'd take level sets of x minus h squared plus y minus k squared, right? But setting this equal to a constant means you're taking a level set of this function. Okay, so all of the circles, in terms of the way you usually see them, they're level sets of this function in particular. Similarly, the same thing can be said about spheres, okay? And I could do ellipses and ellipsoids and so on and so forth. Moral of the story is that it's very, very common to be given a set as a level set of some function, okay? You may have to parameterize it, but okay. Next, so let's take an example. Let me take this. X squared plus y squared plus z squared. Let me make this equal to 14. And I will consider this at the point 1 to negative 3. Okay, and I believe let's check that this is indeed on that level set, on this sphere with radius square root 14. 1 plus 4 plus 9 is 14. So yeah, this is a perfectly good point to look at this sphere. Okay, so if I consider this sphere to be the 14 level set, if you will, of the function f of xyz equals x squared plus y squared plus z squared, then in terms of finding the tangent plane at that point, well, there was this wonderful fact we learned in the lecture on gradients, that gradients point normal to level sets. So if I take the gradient, grad f, I get, well, it's just 2x comma 2y comma 2z. Okay. And now I can plug in my point 1 to negative 3 to get the normal at that point. Two, 4, negative 6. And as it happens, of course, I suppose maybe I shouldn't take a sphere centered at 0. In any case, here is my normal. Here is a point that the tangent plane has to go through. So, if you recall the formula for finding a plane that goes through a point with a given normal, you will then recognize that this vector here, dotted with this vector here, I suppose I could simplify it, but I won't bother. This is giving me the tangent plane. Let me do something slightly similar, but slightly different. Let's take f of xyz to be, how about x minus 1 squared plus y minus 2 squared plus z plus, well, let's just say plus z squared. Okay? And now if I take level sets to this function, I will get spheres centered at 1, 2, 0. Right? Okay, so let's consider a specific one of these points on one of these spheres. So let's say I consider the point 3, 4, 1. Okay, here's a point 3, 4, 1. And this will be on the sphere where what? What's the radius of the sphere centered at 1, 2, 0 that contains? Well, I'll have 2 squared plus 2 squared plus 1, so 9. Okay, so if I have basically the sphere of radius 3, I have f of x, y, z equals x minus 1 squared plus y minus 2 squared plus z squared equal to 3 squared, then this point 3, 4, 1 lives on that sphere. And we can find the tangent plane to that point, or to that sphere at that point. So let's do this. And let me get this ready to move out of my way. Okay, well first I need a gradient of this function. So, gradient of f is equal to twice x minus 1, comma, twice y minus 2, comma, 2z. And if I plug in 3, 4, 1, I will get the gradient vector that I need. Grad f of 3, 4, 1 equals, and let me pull a 2 outside of this whole thing. So twice the vector, well, 3 minus 1 is 2. 4 minus 2 is 2. And 1 is 1. So I have this vector 2, 2, 1. That's my normal. And why don't I make it 2 times the normal, because I'll cancel those 2's and have a simpler normal. Okay, so I can use 2, 2, 1 as a normal, which means x minus 3, oops, let me make this a vector, x minus 3, comma, y minus 4, comma, z minus 1, dotted with 2, 2, 1, equals 0. This will give me the tangent plane to the sphere here, x minus 1 squared plus y minus 2 squared plus z squared equals 3 squared, at the point 3, 4, 1. Now, okay, you could now say, well, hang on a sec, couldn't we have just solved for z and done this the old way? And the answer is yes, we could have done this the old way by basically, if we take this function x minus 1 squared plus y minus 2 squared plus z squared equals 3 squared, we solve for z. And since z is positive, z is 1 at the point in question, I'll take the positive square root of 3 squared minus the x minus 1 squared minus the y minus 2 squared. And then I'll take derivatives of, and it'll be more annoying actually because I'll have to take derivatives of that square root. Nevertheless, you can do it the old way. However, there are fairly simple examples, and some of them are in the homework, where you will not be able to unwind the thing, which is to say, okay, it says find the tangent plane to the given set at the given point by using the gradient. Here's a level set where I don't know how to solve for z. Okay, I can't solve for z, I can't solve for y, I can't solve for x. Not without a computer or looking up quartic functions online. And frankly, I've never done that, but I could find things where looking stuff up online wouldn't even allow me to do it. There are functions which just simply you cannot solve for the z by itself, for the x by itself, for the y by itself. And so when you are given a level set of a function like this and need to find the tangent plane, you have no choice but to take the gradient. Okay, because you can't unwind this. You can't solve for x, y, or z here. It's too intertwined and interwoven. And the same is true for this, in part B. So these problems in particular are examples of problems where you have no choice but to do it by taking a gradient. Now then you could come at this the other way and say, well, hang on a sec, any of these other old problems, if I have z as a function of x, y, let's say equals x squared y, and I want to find the tangent plane, find tangent plane at, and let's make this simple, let's say 1, or no, let's go with 2, 1, 4. That's certainly simple enough. Okay, so my x, y, and really you might even be told just at 2, 1, and make it your job to find the z. Well, 2 squared times 1 is 4, so I did that for you. But how would you do this? You'd say, oh, well, I need f sub x, which is 2xy, f sub y, which is x squared, and then you would say, okay, f sub x at 2, 1 is 4, f sub y at 2, 1 is 4. Oh gosh, I have another one of these examples. Here's what I'll do though. I'll give this a hat and this a twiddle, and then you'll understand what I'm doing in a moment. So z is equal to 4 plus the rate of change in the x direction, and I put the hat to identify it as this one, times the change in x minus 2, plus my 4 twiddle, i.e. the 4 that I got from my y derivative, times y minus 1. And of course the value of 4 twiddle is 4, and the value of 4 hat is 4. I'm just doing this as a pedagogical tool, so in your notes, is because of course my bad luck, I got something where I had 4, 4, and 4. Okay, but so here is the old way of doing it. And I say the old way. If you're given this problem, this is the right way to do it. However, I want to point something out to you. The set where z equals x squared y is the same as the set where the function f of x, y, and z, which I'll take to be defined to equal x squared y minus z, if I take the 0 level set of this function, that's exactly where z is x squared y. Okay, so what do I do if I want to find a tangent plane to a level set at a point 2, 1, 4? Well, I take gradient of big F, and I will get 2xy, comma x squared, comma negative 1. Right? It's my x derivative, my y derivative, and my z derivative. And now, when I evaluate this, grad f at the point 2, 1, 4, I'm going to get, and to write this as, it's the 4 hat, the 4 twiddle, and negative 1. And now I say, okay, x minus 2, comma y minus 1, comma z minus 4, dotted with for hat, for twiddle, -1 equals 0 is my tangent plane. And yes, if you do this dot product out, you're going to get exactly this same thing. So any of the things that you did the old way, where you have a graph of a function, by saying, well, z is equal to x squared y, and then saying, okay, then x squared y minus z equals 0, you can swing things around to make this kind of thing into a level set. Now, please learn both ways, because you really, really want to learn both ways, but as it happens, this way is more general than the previous way. Okay? You can always turn one of these into a problem like this, but you can't necessarily go backwards. For example, these problems on the homework. You can't solve for z as a function of x and y in either of these, or with x or y, and so on and so forth. Okay, so I suppose that's what I have to say about finding tangent planes by using level sets. And I suspect that this lecture will be best to just chop into 3 clean pieces, so I will stop here.